So MediaTek has announced the Dimensity 9500, 9500. It's its latest flagship processor. It's got the latest CPU cores, the latest GPU cores, plus some other neat tricks that MediaTek has added. This has got the potential to be an amazing flagship SoC for smartphones that we'll probably see announced sometime during the rest of this year and into 2026. So if you want to find out more, please let me explain. So less than 2 weeks ago, I made some videos about the latest CPU and GPU releases from ARM. And so I've got a video covering that in general. ARM unleashes 4 new CPUs and a new GPU. And then I've got individual deep dives into the C1-Ultra, the C1 Premium, the C1 Pro. Now, both of these are used in the MediaTek 9500. We'll talk more about that in a minute. Also about the new Mali chip with its 2x ray tracing boost. We'll talk more about that in a minute. I'd also cover the C1 Nano, which isn't in this processor, but that's the full roundup. Now, a lot of the claims that MediaTek are making, a lot of the things they are saying are based on the fact that they're using all of these cores. Okay, so here is the diagram of the 9500. As we can see, we've got C1 Ultra, some C1 Premiums, some C1 Pros. As I just mentioned, we've got the Mali G1 Ultra, and then we've also got their new NPU, and also just note this thing here, the super efficient NPU, along with all the other interesting things, connectivity, modem, and so on. But those are the things we're going to be looking at in this video. So an all new CPU, GPU, NPU, the all big core design. So as with previous generations, they're not using the Nano or what was the Cortex A500 series. They're not using those. They're using only big cores. They're saying we've got console level ray tracing. So again, that comes from the things that ARM was saying about the Mali G1 Ultra. They've got this new NPU. What do we know about it? 30 billion transistors, and on the 3rd generation of 3nm TSMC process. So bleeding edge 3nm process here, 30 billion transistors, all new CPU and GPU. This actually is quite a chip. So let's concentrate on the CPU to start with. We've got C1 Ultra, 3 C1 Premiums, and then 4 C1 Pros. And then look here, 16 megabytes of L3 cache. And we'll talk more about the significance of all of that in a moment. So 3rd generation, all big cores. The 3rd generation from MediaTek using only big core. Higher single core performance. They're saying that the single core performance in something like Geekbench goes up by 32% compared to the Dimensity 9400, and because of the improvements in IPC and because of the improvements in the process node, you've got lower CPU power usage, lowering by 37%. Here we got some clock figures, clock rates for us. So we've got a C1 Ultra at 4.21 gigahertz. Again, if you don't know what is a C1 Ultra, C1 Premium, that's what I've got those other videos for. You've then got 3 C1 Premiums, which of course are basically C1 Ultras, but optimized for space efficiency, and they're clocked at 3.5 gigahertz. And then you've got 4 C1 Pros clocked at 2.7 gigahertz. So that's really quite an interesting clock speed, high clock speed that's certainly going to give you a good single-threaded core performance. And as ARM emphasized during the launch of the C1 Ultra and so on, this new chip now has SME2, Scalable Multi Extension 2, which means that you can run AI models in the CPU. You don't have to send it to the GPU, you don't have to send it to the NPU. It gives you it inline in the CPU. And here they're saying improved object detection compute performance. They're running an object detection model, 57% improvement in speed, 50% reduction in power consumption when running encoding decoding model. That's basically to do with large language models there. So here I've made a quick comparison of the Dimensity 9400 comparing it to the 9500, so we can see some of the interesting things. Okay, so the old one had the Cortex X925, 2 megabytes of cache, 3.62 gigahertz. Here we've now got the C1 Ultra, 2 megabytes of L2 cache again, and now up to 4.21 gigahertz. So the bump in clock speed and the bump in IPC from the C1 Ultra combined are giving you that higher single core performance. They then had 3 Cortex X4 chips because there wasn't an X925 Premium or an X925 or an X924 or something like that. So they went with the previous generation of X-Core, 1 megabyte of L2 cache at 3.3 gigahertz. And now we've got these C1 premiums, which are basically the same microarchitecture as the C1-Ultra, but optimized for space. So that's running at 3.5 gigahertz. So again, bigger boost in clock speed and also a boost in the IPC because of the chip design. And then for the third set of cores, they had the A720s. Now they've gone with the C1 Pro, 512K of L2 cache at 2.7 gigahertz. So again, bump in clock speed and a bump in the IPC because of the improvements of the C1 Pro over the previous generation. But here's a really interesting one. They had 12 megabytes of L3 cache on the 9400. That's now gone up to 16 megabytes of L3 cache. So they've been bumping up the cache at this level. This C1-Ultra actually has some cache changes as well at the L1 level, because that's how the C1-Ultra is designed. Again, I cover that in my videos. And then the system level cache, 10 megabytes, remaining the same. So we're definitely going to see lots of speed improvements because of clock frequency improvements and because of the improvements in the CPU designs. Okay, so moving on to the GPU. So we know it's a Mali G1-Ultra. That's actually a 12-core device, which is what you'd expect at this high-end level. Remember, cores here don't relate necessarily to the same as what core counts might be in, let's say, a chip from AMD or from NVIDIA or even from Imagination. These are specific to how ARM design their chips. Again, all covered in that and previous videos. So what are they saying? 33% improved peak performance and 42% energy efficiency. And then on to the NPU. So they've really have emphasized the NPU here. They've got a generative AI engine. So they've actually changed now the design of the NPU specifically for generative AI use cases. That would include speech, music, text, images. They can all run inside of that. There's a dedicated hardware circuit for a transformer. So transformers are large language models. So they've got some special stuff in the NPU that says, oh, this is a transformer. We can do this in hardware. Certain of those operations that need to happen in hardware. And there's this thing is really interesting. The newly added super efficient NPU. Remember, I noted that in the first slide. It's separate to the main NPU, and it's the industry's first CIM based NPU. We'll talk more about that in a moment, but the overall figure, 2 times integer and floating point computing power. So they've doubled the performance basically. So what do they mean by industry first compute in memory? Well, this almost in itself deserves another video, and when MediaTek maybe give us some more information on how they've implemented that, maybe I'll do that. But basically, remember nowadays, all of the models, the AI models, whether that's a camera model or whether that's a speech model or whether that's a large language model, they're all in the RAM. And for the CPU or the GPU or the NPU to do something on it, it needs to be transferred from the RAM to that device. It needs to process it and transfer it back again. So there's a huge amount of transfer goes back and forth across the buses to and from the RAM using the von Neumann architecture. But compute in memory is basically, well, couldn't we do some of those things actually at the memory side without dragging it into the CPU or the NPU or the GPU? And so what they're saying here is this super efficient NPU has got some kind of direct control over the memory, and it can do things more in memory. MediaTek mentioned it more kind of like a cache kind of idea. It's part of the cache system, and of course the cache system is built into the memory, which means if it's in the cache, I can work on it here and we can write it out to main memory later on, or when we know it's been changed, we can invalidate, you know, all the stuff that goes on with caches. But that's really interesting because they're trying to say that this is going to improve models because of the way they work, and the target here is low power AI models that run permanently. Okay, so we're not talking about large language models that take up 1 gig, 2 gigs, 3 gigs of RAM. We're talking about maybe something to do with the camera, something to do with sensors, but it can run basically permanently because it's got this ultra efficient NPU, and the model doesn't have to keep shuffling back and forth from the main RAM. Very interesting idea. It'll be interesting to see how it's implemented from a technical point of view and how it's used practically. Okay, so here is an overall summary. We've got changes to the CPU, as we saw, the C1-Ultra, the C1 Premium and the C1 Pro, and of course the support for SME2. We've got the new Mali GPU, which offers 2 times ray tracing performance. That was part of the Mali announcement, and then the other numbers that go with that there. Obviously, there are other things, 5G, for example, that's built. It's a 5G processor. Obviously, we've got lots of multimedia stuff with, for example, Android's first 4K 120 Dolby Vision video capture, for example. And then, of course, we've got this NPU, as we just talked about, with basically 2 times boost in performance at the NPU level. So as I said, that is pretty good, pretty exciting launch. It'll be really interesting to see it in handsets, see it performing, see battery life and all those kind of things. So let's see what comes down the pipeline. Okay, that's it. My name is Gary Sims. This is Gary Explains. I hope you enjoyed the video. That's it. I'll catch you in the next one.